Good evening. I hope everyone can hear me very clearly. Okay, then we can proceed. My name is Buddhika Padiratna. I'm a secretary to the IESL Kegalle District Centre, session 2022 and 2023. So basically, this webinar is conducting collaboration with Aqua Faculty, which is a reputed educational institute that provides engineering knowledge, especially on water supply sector. When we talk about them, they have conducted numerous online and physical education related to the water supply engineering during last 2 and 3 years. On behalf of the IESL Kegalle District Centre, I would like to take this opportunity to show our gratitude to Aqua Faculty as well as those who are supporting to organize this event and to be successful this event. So once again, I welcome all you to this event, this webinar session. Actually, we believe that this session definitely would be a chance to gain knowledge, learn about the engineering practices on drinking water treatment process. Today's water treatment practice are heavily depend on the conventional treatment process. Even though there is much of cutting edge technologies out there, so in some way these technologies are integrated into the field of water treatment sector, but conventional methods are always core subject of this vast field. This core principle and practices are remain same since its beginning. However, if we consider somehow so-called climate change and other environmental factors may affect to the drinking water environmental and as well as other industries, somehow we believe learning about the core values is essential for the who are engaging in this sector as well as who are fascinating about this sector. Basically, that thought was originally drive us to organize this kind of introduction sessions, partnership with some expertise on this field. As I told before, the Aqua Faculty is the expertise we can take into this event. Top of that, this would be the webinar that will start from the very basic level of introduction to the drinking water treatment, as well as it will reach up to some level of advanced processes as well engineers practices regarding this field. So when I talk about the today's session, it's mainly will start from conventional water treatment process, which are basically focused on the basic unit process used in the conventional water treatment, and the brief introduction to the mechanism and the principle used for the water treatment in those unit processes. This session especially for the young engineers who are fascinating about the water treatment, as well as this session also will bring many advantages those who are willing to gain knowledge regarding these specific fields. Next, most importantly, I am glad to introduce here our resource person for today's webinar, Manager to Water Supply and Water Treatment Scheme of Sitawaka Export Zone, Engineer Anuradha Bandara. Very welcome you to this event. We pleasure to have you in here. We warmly welcome you on behalf of Kegalle District Centre Institute of Engineers, Sri Lanka. Good evening, sir.
Good evening, Buddhika. Thank you
Yes.
so much.
Yes.
Thank you very much for the introduction.
Yes. Let me introduce you furthermore with detail regarding yourself. So, Engineer Anuradha Bandari is postgraduate. Engineer Anuradha Bandari is a field chartered engineer with more than 20 years of experience in field of water supply and wastewater. And also he received a bachelor degree in civil engineering from the University of Morocco in 2009, and also his postgraduate degree in the urban water and sanitation from the IESL Delft, Netherlands in 2021, and also has a postgraduate degree from the Integrated Water Resources Management, the University of the Peradeniya in 2018. So he is currently working as a manager of the water supply and waste treatment scheme of Sitawak Export Processing Zone, as I mentioned before, in capacity of the chief engineer. So I will go into the introduce outline of this webinar. I will hand over to you this audience to continue these sessions furthermore.
Okay, thank you very much, Engineer Buddhi, for your introduction. So actually, I just want to make a small correction. My total experience is about not that much 20 years, but it's about 14 years. Okay, so that's a small correction, but it doesn't matter. So let me share my presentation first. Give me a minute, okay? Okay, I hope you can see my screen.
Yes, I can see.
Okay, thank you, Buddhi. Thank you. So today we are going to discuss about the drinking water treatment. So as Engineer Buddhi explained, so this is the basic introduction to the drinking water treatment. However, I think this is very important topic for all of us because of the ever increasing demand for the drinking water treatment and the deterioration of our water qualities due to the various human activities. So it's high time for us to learn the basics of the drinking water treatment, even though you are not a drinking water supply engineer or professional in the drinking water treatment. So therefore, I would like to thank chairperson of Kegalle District Centre, Engineer Aqua and my good friend from the Aqua Faculty, Engineer for inviting me to discuss this topic with you. So, first of all, I would like to give more share what I know about drinking water treatment. Then we will be able to discuss and share your wisdom on this subject during the discussions. So I will give you a brief introduction or brief description of how I organize this presentation. So first, I would give you an overview of the available freshwater sources in the in our planet. Then I will briefly discuss about the water sources and the water. Then I'll discuss briefly on the historical evolving of the drinking water treatment. Then the quality aspects. I introduce some of the quality aspects in the drinking water treatment. Then I'll discuss about the difference between the guideline and the regulation of water treatment. Then discuss maybe about the objective of the drinking water treatment and the pollution classification in regarding to the drinking water treatment. After all the background, then I am going to introduce you the conventional water treatment, briefly explain the principles and mechanism of each and every unit processor. About the conventional water treatment. So let's begin. So I think you may all have seen this this figure. It was developed by the US Geological Survey Water Science School way back in 1993. So from here we can see that the total global water, it's only about 5% is available after fresh water. So all other things are saline or saline water. From this 2.5% of fresh water, majority or 70% is gaseous and available in the gaseous and ice caps. We may not be able to access those water. So the only accessible water percentage is about 30%. From that also the surface water or other fresh water available is 1.2%. So even we can go further into the breakdown of the surface water. However, so from this figure we can see how the fresh water and this scar resource is not evenly distributed throughout the there is a high temporal and spatial variation in the distribution of the water. So the some of the countries have plenty of water, while other countries doesn't have even for the water for the to fulfill their basic needs. So that's why the drinking water treatment is much important aspect when we consider this scarcity of the drinking water. So what are the water sources available and what are the so water sources? We have groundwater sources. Mainly we are taking the groundwater from the dark wells and the tube wells. We have a surface water, rivers, tanks, and ponds are the surface water reservoirs. Then we have seawater or saline water and the glaciers. When the water treatment method, there are many methods available, conventional and advanced method like DAF, ion exchange, and the RO filtration like this. There are many methods. But when we selecting the suitable method for the drinking water method, we should consider the raw water quality and the required water quality because we have to decide, we have to select our treatment method based to suit with our raw water quality, and it should be able to deliver the required water quality. Then again, the other important factor is operation and maintenance. So we can build a very big, high sophisticated water treatment plant, but if the local people or the users doesn't know how to operate or maintain this treatment plant, that will be a failure. So we have to consider that factor. Then
Engineer
yeah.
Engineer Anuruddha,
Yeah.
I think the voice is not bit clear. I think there are some these days due to bad weather. I think there are some data issues. I think it's better if you can switch off your videos and continue the presentation. I think it will bit improve your voice clearance.
Okay.
Clarity.
I'll
Yes.
do it. Okay.
Thank you.
Okay. I have switched off my video. So how is now? Is it clear, Engineer Daraka now? Or
Yes.
otherwise-
Now it's bit clear, right? You can
Otherwise,
continue.
I can use my headphone also if it is not clear, still not clear. I don't know whether is that a problem.
Now I think it will be bit clear rather than previous one.
Okay.
We'll continue under this condition and we'll see if it further disturb, we'll improve that way also.
Okay. So Thank you very much, Engineer. So, I was discussing about the factors to be considered. I have when we selecting a suitable water treatment method. So, I have explained about quality required water quality and the operations requirements. The least but the last but not least, the capital and cost. We have to consider about the both, because sometimes you can invest low, you can have a water treatment facility with the low capital budget, but you have a high operation maintenance cost. So for give a better output, we have to consider total cost of the lives by considering capital and O&M cost both. So, I would like to briefly give you an idea about the historical development of the water treatment. So the first regions of the drinking water treatments goes back to the 400 BC. So Sanskrit and the Greek writings, they recommend to boil water on fire or heat in sun or dip in a heated iron. So basically they are recommended to heat water before consuming. There are evidence around 1500 BC about in Egypt they have used the chemical alum to settle the suspended particles. That is same thing we are doing in the our conventional wastewater treatment. Around 15th century, the father of medicine, Hippocrates, invent something called Hippocrates sleeve, a cloth bag to strain rainwater. Then that's another treatment method, and he recommends to boil the water. In third century BC, public water supply schemes are developed in Rome, Greece, and Egypt, and many of the large civilizations during that time. Again, from 340 BC to 225 AD, during the Roman Empire, they were very advanced civilizations. They built this aqueduct system to transport the drinking water to their people in the cities. So this aqueduct system has the capacity of the deliver about 5 lakh cubic meter per day to Rome. So this is a specifically time, and this is a very, very marvelous engineering example. After the falling of the Roman Empire, during the dark age of the water treatment is not developed. Water treatment, they pay not much attention to the water treatment. But after the end of the dark ages, again emerged the interest in the water treatment. So in 700, domestic level filter was developed in France. When in 18, the first municipal water treatment plant is installed in Scotland. So all wonder talking about the history about the water treatment in the Europe, but in our country. So අපිටත් ඉතින් තිබ්බ water treatment ක්‍රමයක්. නමුත් මේ well written document නැති වුණාට අපි ඉංජිනේරට දාලා ට්‍රීට් කරලා තියෙනවා වතුර, අඟුරු දාලා ට්‍රීට් කරලා තියෙනවා වතුර. That's all something similar to somewhat similar to the current activate carb filters. So we also had some development in water treatment. So however, we consider this ancient or the old water treatment system. They were not understand the relationship between the quality of the water and the health concerns. So all they may not appreciate this much, but the taste, odor, etc. However, in 19th century, this gentleman, Dr. Snow, found the relationship, or found the trace back to the origin of the cholera disease to the water treatment plant in London. So then all the scientists are interested in this new finding, and they were started research about this one, and then they found about the microorganisms and pathogens who lived in the drinking water and who caused the illness to the people like cholera and typhoid. So then it started to develop the water treatment technologies to address these issues. And in late 1800 and early 1900, during that time, coliform tests that test used to the that test used to the identify the presence of the coliform or fecal contamination in the drinking water was developed, and the conventional water treatment process was also developed during that time. So the first 100 years from the mid 1800, the water professionals or supply engineers mainly focused on the preventing the waterborne diseases outbreaks. So they were, the main focus was at the preventing the outbreak of the some diseases like cholera, typhoid. But in the 1970s, that kind of was shifted because of the population concerns are shifted from the acute illness to the chronic health disease. So mainly the anthropogenic chemicals, heavy metals, and infection byproducts are they were found that they were causing the chronic health effects. So then the water treatment interest to the how to track the issue since 1970s. Now the especially in the developing countries, they are more focusing on the removing those kind of impurities rather than the focusing on the preventing the spreading waterborne diseases that they have already achieved. So, I'd like to discuss about the quality aspect. Discussing the quality aspect of drinking water. So the main document or main guideline is provided by the WHO, guideline for the drinking water quality. So this guideline highlighted or provided the guideline value for concentration does not risk any significant risk to health for long-term exposure. Here also they are considering about the this chronic health effects, not the acute illnesses. So it recommends that drinking water should be free from microorganisms and the chemical and radioactive compounds which are harmful for the health. They are not limiting from that one. Then they are recommending that the water shall be free from the pollutants or the impurities which cause the consumer to reject the water, like the turbidity, color, taste, and odor. Those may not be affect the human health, but these parameters the cause the people reject the water, and also invertebrates like worms and the fly nymphs. So these are the main recommendation. They have specified the recommended value, but I just summarize what they have specified here. So first, it should be free from microorganism and the chemical that cause the health issues, and also it should be free from the things that the consumer question about their safety. So then the WHO give you a guideline. So we heard these terms. What's the guide? We heard the terms guidelines, standard, and regulations. So what do you mean? What do we mean by those words or those things? Guideline is the advice. So WHO has given the advice. They as per the scientific evidences, they are giving advice the people that how something should be done or something should be done. So that means they are advising us to water quality should be free from these. Like, but the advice, then the standard means based on these advices, something like organization group standard different countries, they can develop the standards. They may have adapted capacity, so they have modified it according to their needs. So that is we call a standard. But standard, having a standard does not that it's a law. So it may be adapted or may not be adapted. So something to become a law in a country, it should be a regulation. That is the end. That is the something forced by a government. Guideline is basically advice. That is standard something like a bureau. Or when this is enforced by government, it becomes regulation. I hope you are clear about this difference between the guideline standard and the regulation. So then I would like to move on to the objectives of the drinking water treatment. So the main objective, prime goal of the drinking water treatment is the protect human health by removing pathogens, chemical contaminant, and radioactive substance. Then its objective is to improve the aesthetic aspect of water, like color and shade, just make the water accepted by the consumers. Then there are other factors like operational economical concerns. That means the water shall be non-corrosive and shall not cause the incrustation of the pipeline, stain in the cloth or safety of the equipment. These are some of the operational economical concerns of in the drinking water treatment. We are one of the objectives is to address these issues. Then, apart from the removing the pollutant or impurities from the water, another important aspect of the objective of the drinking water, you know that fluoride is required for your dental health and the oxygen. Likewise, sometimes the objective is shifted to the shifted from the removing, but it's rather adding essential element to the drinking water. If you can see this graph here, it's got the water treatment of objective and principles against the social economic level or institutional capacity. You can see here when the social economical level and institutional capacity is low, the water treatment objectives are mainly focusing on the removal of the bacteria, virus, protozoa, and the arsenic, chloride, solid waste, and those are the mainly concerned about the human health. But when you are social economic level improves, it's the objective is more shifted, removing of the chemicals, toxicants, and traceable organic matters. So those are the things that are not just immediate health issue, but acute health issues. For this high socio-economic conditions demand high water treatment objectives and priorities. So in Sri Lanka as a developing and currently backed up country, we are still around here. Our water treatment objectives are found here, but some of the developing countries, European countries, and the United States, they are mainly focusing on these areas of objectives. So this is the rough classification of the pollutant and impurities in the drinking water. So pollutant and impurities we can classify into three branches mainly: physical, chemical, and biological. So physical pollutants we can further classify into as gases, liquids, and solids. Then the chemical pollutants we can classify it as organic and inorganic. Then the biological pollutants or impurities we can classify pathogenic and non-pathogenic biological pollutants. So that in the physical the solids we may be able to further classify as floating, settleable, and colloidal particles, and the dissolved particles. Floating, settleable, and colloidal particles rather easily removed from the water when compared to the dissolved solids, because this may need the advanced water treatment method. For the chemicals also, the organic and inorganic chemicals, there are different treatment methods to remove those organic and chemical methods. But in chemical pollutants, we can identify what are the pollutant caused risk to the human health, and we can remove. But when we consider the biological contaminant, it is not possible to identify the pathogens and non-pathogenic microorganisms. So mainly what we are doing is removing all the microorganisms from the drinking water treatment. So based on this background knowledge, I would like to move on to the conventional water treatment method, that is most widely used water treatment method. Then I will explain each and every the unique processes of this involved in the conventional water treatment method briefly. So first of all, I would like to introduce the conventional water treatment method. The conventional water treatment method is the treatment method was developed in early 1900s. So this treatment method consists of many unique treatment processes. Like here you can see the first is the screening. Then we have the pH correction, maybe oxidization and disinfection. Some of these unit processes may not be available in each conventional water treatment method. There are maybe some modification. However, this oxidant and the adding the disinfection are available in some of the conventional water treatment plants. Then we have a main treatment method called coagulation, followed by the flocculation. I'll explain about these processes. Then we have sedimentation. Then after the sedimentation, we will have a granular filtration. Sometimes we add filter aid before the granular filtration. Sometimes, the most of the times there is something like that in the water treatment plant. After the granular the filtration, the water is disinfected, then storage in the clear water storage tank and distributed for the. So this is the main unit processes involved in the conventional water treatment. So this is a photograph of a water treatment plant. So you can see here the aeration basin, and here we have the chemical mixture and the chemical mixing and the coagulation adding. So this is a hydraulic conjugator or hydraulic mixer. I'll explain later what are the hydraulic and chemical mixtures. Then here takes the population and the sedimentation, and the mixer over there. So now we will discuss each and every unit processes briefly and discuss the mechanisms and the principles involved in those unit processes. So first, I discussed about the screen. As this name stated, that screening is the screening from the water remove the large protein object like logs, fish, plastic, debris, dead animals. Likewise, the main objective of the screening is to remove those from the raw water. So why we do this process? So mainly we are doing to protect our structures, equipment downstream in the treatment plant. So there are mainly two types of screens: coarse screens and the fine screens. The coarse screen size, the opening size varies from 32 to 100 millimeter. Then fine screen opening size varied from 1.5 millimeters to 13 millimeter. So we can classify screeners on the cleaning method also. There are manually cleaned screens and the automatically cleaned screens. The manually cleaned screens means that we collect the debris or the protein matters stagnate before the in front of the screen by manually. Otherwise, we remove it by the mechanical means and clean it using the water. So commonly these screeners positions at the intake in an intake channel positions at the angle of 60 to 90 degree with the horizontal. So these are the some of the photographs of the mechanical screeners. So you can see here this screener is stationed or placed in the intake channel, and this screener has the facility to clean them mechanically because this screen can lift by the motor over there. So these are some of the screener photographs of the screeners useful in the water treatment. So then after this screening process, there is a process called aeration. So aeration is the process aeration is the meaning of the aeration is the bring. There are two activities take place during the aeration. One is bring gas contact with air, then take place the gas transfer, that is the transferring gas into water or out of the water. So we use this aeration to add some essential gases to the treatment process, adding oxygen and removing some toxic gases from the water like sulfur dioxide, methane, ammonia, and some of the volatile organic compound also, removing this aeration during the aeration. So there are many types of aeration. Like here we have a aeration, cascade type aerators. So basically what we are doing is that we are increasing the surface area contact with the air to for efficient gas transferring in the aerator. And this is another type of aerator, spray aerator. The same principle takes place here. We spray water into the air, increase the surface area with the surface area contact with the air. So then I will introduce you another treatment step we call is pre-chlorination. So the method of pre-chlorination is the adding, that is basically adding the chlorine. So we call it pre-chlorination because this chlorination takes place before the main processes of the water treatment. So during the pre-chlorination, we are dosing high concentrated chlorine which is range from 2 to 5 milligram per liter to the water. So purpose of this is the keep it this chlorination is keep activated throughout the water treatment process. However, there are consequences, or there are issues with this one. I'll explain it later. So before that, I'll explain why we need pre-chlorination. Mainly, we are using pre-chlorination. We all know that chlorination is a very strong oxidant, so we use to oxidize some of the ions or some of the metals in the drinking water, like ferrous, manganese. And we use the pre-chlorination, remove the algae and pathogens from the water, and we use pre-chlorination to improve the odor and color. However, due to the develop of the interest and the develop of the knowledge of the disinfection byproducts in modern water treatment, this is not recommended. Can I have a minute, please? Excuse me, I got a call that from one of my colleagues that he mentioned that it's not still it's not clear. So give me 1 minute. I will change to the. I will wear my headset. Maybe it will be much clearer after that time. Give me 1 minute, okay? Can someone, if you hear me clearly now?
I think you can continue. I think you can continue, Vikram.
Engineer Anuruddha, you can continue. Then we can see what we need. Engineer Anuruddha, can you hear us? Engineer Aniruddha, we can't hear you. Please.
Yes, we can hear you.
Okay. I think my headphone is not working. Then I'll switch back to the computer microphone. Anyhow, can you hear it now again?
Yes, yes, yes. That's
Okay,
good.
I'll continue this way. I'm sorry for the bad voice. I don't know what's the problem with it may be the problem with the connection or the problem with the microphone. Anyhow, sorry for the disturbances. I'll continue with my presentation.
Yes, okay, thank you. Yes.
Okay, so as I explained before this interruption took place, the pre-chlorination is not recommended in the modern water treatment due to the formation of byproducts. So because when we are doing the pre-chlorination, lots of organic matters and other impurities is present in the water. Because of that one, it's promote the formation of the disinfection byproducts. So then I would like to move on to the main treatment unit processes in the conventional water treatment method. Before go into the details of this treatment method, I would like to explain you about the settling time and the particle size. So if you take, if you can see here the particle size like gravel, sand, fine sand, clay, and the bacteria and colloidal particles. So if you get the water with these particles at in a stationary tank or a tank in which at rest. So the settling time of the particles, the settling time take to settle 1 meter of depth in the water for each size of the particles. You can see here, gravel only take 1 second, sand take 10 seconds, and fine sand take 2 minutes. But it is take hours to settle 1 meter. Bacteria 8 days. Colloidal particles take 2 years. Some of the colloidal particles size of 0.1 micrometer is take up to 20 years for the settling of 1 meter. So from here we can say we are not able to do this bacteria and colloidal particles from the water, just keeping it at the stationary or keeping it at the as it is in a tank. We don't have that luxury to wait 20 years to treat the so before the going into the detail of the solution, so I would like to do brief introduction to these colloidal particles that size start from the 0.1 micromillimeter or below. So this how these colloidal particles form. So mainly there are main two methods. One is the biosynthesis, that is the insoluble organic matters formed during the chemical reactions may produce a stable colloidal particles. Then another method of forming those is the size reduction of matter due to the grinding of the coarse materials. So when the coarse material grinding with each other, it form fine materials. So that can become colloidal particle. Then material with high molecular mass or lone polymer chains can be insoluble in water. So that can form a colloidal particle. For example, a product of the humus form colloidal particles in this way. In the natural phenomena like erosion of the rocks, weathering of rocks form colloidal particles. So how is the behavior of these colloidal particles? So colloidal particles are electrically charged. It's electrically charged. It's when the colloidal particles are in the water, some of the elements attached to their lattice, crystal lattice, may dissolve in the water. Then it will create a electrical charge void. Then, because of that one, the solid particles are electrically charged. Then, what happened in the water? There are many ions, positive and negative, because of this presence of the because of this charge in the colloidal particle. Let's say, as example, if you consider this colloidal particles charged with the negative electrical charge, all the positive charges in the water, electrical charges in the water attract it and absorb its surface. So after absorbing these positive charges, there are weak diffuse layer formed adjacent to this adsorbed layer. We call this adsorbed layer stern layer and other layer diffuse layer. Then there is a potential barrier or electrical charge barrier is developed next to these colloidal particles. So we call these layers are double layers, and these double layers are preventing collision and agglomeration of the colloidal particles to form much larger particles. So that is the solution is the coagulation. We call coagulation and percolation. So what is the coagulation and percolation? I'll explain it later. What do we mean by the coagulation and the percolation? We use the coagulation and percolation to remove suspended and colloidal particles, basically remove the turbidity from the water. And while we are doing that, some of the dissolved matters like phosphorus, natural organic matter, fluoride, heavy metals, all those are removing. Portion of those are also removing during these two processes. So because of that, we call this is a multi-purpose technique, this coagulation percolation. So most common coagulant used by today's drinking water treatment is ferrous sulfate or copper ash and aluminium sulfate coal alum. So in Sri Lanka, we mainly use the alum because we don't have much iron processing factories. Some of the countries we have the steel making factories. They are to use this copper ash or ferric sulfate, but in countries like us, we are mainly using alum sulfate. Some of the water treatment plants use the electrolytes as the coagulants, but it is not much common, no much popular for the world. So, what is what we are doing is during this coagulation and percolation? Mainly, we add coagulant water in the coagulation to stabilize the colloidal particles. The colloidal particles are very stable in the normal condition in the water. So that's why it's very hard to settle those things. But because of that, we need to destabilize these colloidal particles by neutralizing their electric charge and overcome their potential barrier. So because of that, we are adding this coagulant or alum or iron water. Then why we call this coagulation process? We call it rapid mixing. Why we call it rapid mixing is after adding this coagulant, we have to mix the water rapidly to avoid the first we want to distribute this coagulant throughout the water efficiently. That's why we are mixing it rapidly. And other thing is preventing the forming local high concentration areas. Then it will help to re-stabilize the colloidal particles. I'll explain how it is happening. Now, let's say if there is colloidal part has a negative charge, then the positive charge coming from the iron can neutralize it. But if you have a more iron sulfate, then it will adsorb to the colloidal particles and make it positive charge colloidal particle. Then it's again very stable. So to prevent these things, we have to mix the coagulant with the water rapidly. Then after that, the collision and the agglomeration take place. So for this to take place, we have to mix water slowly and increase the number of collisions in each particles. So we call that process is flocculation. So after the flocculation, we will sediment or settle the large particles or agglomerate colloidal particles in the settling basin. So these are some of the coagulation, flocculation instrument we use. So normally this is the mechanical type coagulators, popular vertical mechanical type coagulators. The popular is used to mix the coagulant with the water rapidly. This is the horizontal type coagulator, and there are hydraulic coagulators also. Hydraulic. Now, what we need when we are adding the coagulant, we need a high turbid water. So we can cause this turbulence by mechanical mean or by creating hydraulic jumps. Some of the treatment plants use this hydraulic jump. Some of the treatment plants use this mechanical instrument for this rapid mixing. Then after that, we are slowly mixing water. For that also there are mechanical mixers or something like baffle flocculation basin, like this is a hydraulic flocculator. So how this destabilization of the colloidal particle takes place? I will briefly explain this mechanisms and these theorems are go very deep. I may give you a very brief introduction of this mechanism. So the first, when we add in this iron salt or the ferrous alum sulfate to the water, it started to form complexes in the water. Then adsorptive coagulation means that colloidal particles are adsorbed to these complexes. Then there is another method called precipitation or sweep coagulation. In this mechanism, what is happening was the growing flocks are captured the colloidal particle to their flocks. Then we call it sweep or precipitation coagulation. So then another method we call interparticle bridging. That means the very long polymer or polyacrylate chains which help to bridge two colloidal particles to each other. So these are some of the mechanisms, the theory and the mechanism about this one. If you want to understand more about this one, you have to spend more time on this one. So I will just briefly explain these things. But this theorem and the principles behind deep. After the forming these large particles, so the agglomeration of these colloidal particles, we can see these kind of flocks. This is the photograph taken from the laboratory experiment. However, you can see here on the left-hand side, we can see fine particles, but it cannot be easily settled. But here we can see the large blocks which are easily settled under gravity. So after this percolation, we have the process called percolation. So during the percolation, what we need to do is we need to this demineralized particles. How we are doing is we give the kinetic energy to these particles. There is an energy barrier for the agglomeration. So we have to overcome this energy barrier. So that we have to give energy. How we are giving the energy is we are providing the kinetic energy. That's what we call the mixing. Mixing is the way of giving the kinetic energy to the water. So after this sufficient kinetic energy, particles collide with each other and make large particles. However, when the particles become larger and larger, there is tendency to break the particles again. If you mix with high energy. So normally what we are doing is we are creating the velocity gradient throughout the population basic. When the particles are small, we give high energy, but when the step-by-step particles become larger, we are reducing the energy. So that's something about that's what I would explain about the percolation. Then I would like to move on to the sedimentation. So the sedimentation can explain from the structure. So, but I don't want much detail on into that one. However, you all remember the Stokes law we learn in the level physics. So if you take this kind of particles, there are two forces acting upon that one initially. One is the force due to gravity and the force due to buoyancy. So normally this gravitational force is larger than buoyancy force, so this particle started to move downward. When the particle is moving downwards, or the moving through the liquid or water, due to the viscosity of the liquid, the drag forces started to form. So this drag force is proportionate to the velocity of the particles, moving velocity. So at some point, this all the forces become equal. Then the velocity is not increasing further. We call that velocity is the settling velocity. This is the settling velocity derived using the Stokes law. So this is the graph show cumulative frequency distribution of the settling velocity. You see how I'll explain from the one of the examples. If you take settling velocity of the point 0.6 millimeter per second says that the particles, 70% of the particles has the settling velocity below the 0.6. That means if we design a settling tank with the settling velocity 0.6 millimeter per second, we only be able to settle the 30% of the particle. So the removal ratio is only the 30%. So then if you go for a less settling velocity value, let's say it's a 50%, then we may let's say it's 0.4 millimeters per second, then we may be able to remove the 50% of the particles in the water. So likewise, we can, if you can develop this cumulative frequency distribution, distribution of the settling velocity, we can, based on the removal ratio, we can identify for what settling velocity we should design the settling basin. So here also I want to explain something. So even though this explained that 0.6 and below particle, it says that the 0.6 millimeter velocity particles, if you select the other larger particles are not settled, we have a portion of that. And let's say if you consider this black color dot, when the black colors are settling, some of the other particles or the larger particles are also settling. So if the black color particles are completely settled, after when these are completely settling, some of these other particle portion of those particles also settled in the tank. So I need to explain how these particles are settling in the settling basin using this vertical force sedimentation tank. So if you take these particles with let's say as we discussed here, these particles has the settling velocity of 0.6 millimeter per second. So if I design this settling basin to settle these particles, the pathway of these particles in the settling basin is like this. It's going to this diagonal. So when the particles comes to the end of the settling basin, it will travel from top to bottom. So if you have a particle with larger settling basin, settling velocity, it will be settled somewhere here. But if this particle has less settling velocity, maybe it will escape from the settling basin. So this is basically the how the particles are settled in the settling basin, and there is a parameter or the criteria called overflow rate. That is something similar to the settling velocity. We can calculate it by dividing flow rate by the cross-sectional area. So this graph will show you how this particle velocity or the removal ratio and relationship between the overflow rate. So if you have a less overflow rate, you have a high removal ratio. If you have a high overflow rate, you have a less removal ratio. So the sedimentation, we can, there are different kind of classification based on their direction of flow, based on shape, based on the mode of operation, and based on the sludge removal methods. So all the settling basin has the sludge removal mechanism or method. For the settled at some of the sedimentation basin draw from the system and treated separately. Main treatment method is the drying under the sun. So there are some of the sedimentation basin can be classified based on the sludge removal method, like intermittent sludge removal, low continuous such removal. It show you a horizontal flow sedimentation basin and with hydraulic rate. So there is another type of sedimentation basin, the vertical flow circular sedimentation basin. We call such clarifiers, or we call these are clarifiers. The shape of the sediment basin is circular, and the flow direction is up vertically upward, and supplement water from here. This you can. I don't know whether you see this collection trough here. There are some special kind of sedimentation basin with the laminar plate settlers, so to increase the surface flow rate, so the can increase the efficiency of the sedimentation basin, and we can use very, if you have a limited spaces, it's better to go for the sedimentation basin with the laminar plate. So after sedimentation, the next process is the rapid sand filtration in the conventional water treatment. So the mechanism of the removal of the particles or solids in the rapid sand filters, there are three main methods. One is straining, second one is absorbed into the surface of the particles, and the other one is absorbed into the sand particles. So all these three removal processes are taken place in a rapid sand filter. Then based on the flow rates or flow control, we can classify filters into two categories: the constant rate or decline rate filters. I'll little bit explain about this one. So with the clogging of the clean in the clean taking place in the sand filters, the head loss in the filter is increasing. So if you want to filter water in the same rate, so we have to overcome this additional head formed due to the blocking or clogging take place in the filter. So normally what we doing is it's allow water column to the increase its height, then it is rise the water level in the filter, and it will be able to filter water in the same rate. But if you have a fixed head, what is happening is, due to the clogging, due to this the additional friction loss, the flow rate will be reduced. And the filters can be classified based on the number or material used. Sometimes we can use the single material, sometimes we are using the dual or multi media materials in the filter. So here you can see it's a sample or the prototype of the filter with the three medias. Bottom layer is a gravel layer. In between we have a fine sand layer and the anthracite layer. So the advantage of adding the anthracite on top of the sand layer is we can have a higher filtration rate and the longer filter run. So there are some advantages. Meanwhile, if you are not properly designed this treatment, these filters, you may face the loss of operational problems also. So this is a general arrangement with sand filter. So you have a supporting gravel, filter media, and under this supporting gravel layer we have the under drain, let the filtered water, and this filtered water is directed to the water tank. Then there is a facility for the backfeed. So we pressurize water to this under drain system. Then the water will be back flow through the filter and collect wastewater drops and the remove from the filter after the backwashing. So this is the general arrangement of the filter of a rapid sand filter. So these are the typical parameters related to rapid sand filter. So filter media, the diameter effective size of the filter media range from 0.5 meter to 2 millimeter. And filter media normally placed a vessel or tank. The bed depth of the filters may vary 0.5 to 2 meters. General filtration rate varied from 5 meters per hour to the 15 meters per hour. We get the depth of the supernova point from 0.3 to 1.5 meters. Suspended and colloidal particles are partially removed, and it helps to lower the density in the filters. And the filter is getting clogged because of these removed particles. Then after clogging, we have to backwash the filter. So that is the normal situation of a rapid sand filter. So I just want to explain about this graph a little bit. So after the backwashing, it takes time to ripen. We call it back to its normal state. We call ripening of the filter. So during this ripening filter, we can see the ability in the effluent of the filter. And after this ripening, it will be able to operate smoothly and filter the water and provide good quality water for some times. But after some times, start to clean, then the effluent quality is getting deteriorated. So somewhere here, if you fix the standard at the view, then somewhere here you have to backwash the filter. So filter backwashing. This is the typical sequence of filter backwashing. Normally we close the inlet, allow water, remaining water to filter. And we carry out the air sparring. And we add water, pressurized water. That means the air blower and the single pump is running. Then we stop the air blower and run the pumps until the filter is cleaned up. So the final the process I'm going to discuss about conventional treatment is disinfection. The intended purpose objective of the disinfection is to remove the pathogens, kill the microorganisms in the drinking water. So this disinfection or removing of the pathogens not only take place during this disinfection. Please keep that in mind. Most of the pathogens and microorganisms removed in the upstream processes like coagulation, sedimentation, and pit sand filtration helps to remove these pathogens from water. But however, the remaining pathogens is removing from this disinfection process. So the mechanism of the disinfection, what we are doing is we destruct the cell structures of the microorganism during the disinfection process, and sometimes we interface with the metabolic activities of the microorganism and protein synthesis using the disinfection in the disinfection process. So mainly we use the chlorine as the disinfection. So the disinfection chlorine in Sri Lanka, we have basically used the chlorine. I'll explain you later about other disinfection used worldwide. Disinfection react with organics and inorganics. Then disinfect the chlorine consumed for the inactivation of microorganisms also. This all the requirement we call the chlorine demand. So when you're using the chlorine, we have to check the water contact with the chlorine for certain amount of period, we call it the contact time. To facilitate this, we need the contact basin. This is the typical arrangement of a contact basin. We need to have this baffle arrangement into this kind of basin to provide plug for conditions in the system. These are the basic and rough introduction. If you want to learn about the disinfection process, there are many things we can discuss. However, I'm not going to discuss much about due to the limited time availability. So the disinfection, the desired properties of a disinfectant chemical, these are the desired properties. Should be quick and effective killing. It should be able to quick and effectively kill the pathogens, and it should be readily soluble, provide residuals, and it should not give taste, odor to the or color to the water. It should not be it should be non-toxic to human and animal life, and it should be easily measurable in the water, and safe to handle, easily apply and control, and readily available at the reasonable cost. These are the desired properties of a disinfection chemical. However, we may not be able to find a chemical with all these desired properties. However, most widely used disinfection in the world is the chlorine. Chlorine has most of these properties. However, chlorine has the using of chlorine in the world or developing countries now getting depromoted or getting reduced. Why was that? Is the risk of forming the disinfection byproduct. However, WHO advised disinfection should not be compromised by attempting to control the disinfection byproduct. That is, the disinfection byproduct cause acute illnesses, but the pathogens call immediate illnesses. So they recommend not to avoid or not to compromise the disinfection to avoid these acute illnesses. And these are the how chlorine is available in the market. This is the gas chlorine. We are using gas chlorine. Sometimes we are using this bleaching powder, calcium oxychloride, and sometimes we are using sodium oxychloride also as a disinfection in our water treatment plant. So with that, I would like to conclude my presentation. So before the concluding, I would like to add some concluding remarks. So the conventional water treatment is most common and widely used water treatment method in the world, in Sri Lanka also. So the many combination of these unit processes I have discussed used in the water treatment plant. Some combinations, particular water treatment plant has a different combination to the compared with another water treatment plant. Also, this the conventional treatment can be modified using disinfection, advanced disinfection type of ultra UV detection, or ozone disinfection, or activated carbon filter, or biological filter. Likewise, there is a flexibility in the conventional water treatment to your requirement. However, it is required deep understanding for optimization and designing these processes. So during this presentation, just give a brief introduction, and I did not went too deeper into these processes. So, but you need a very good deep understanding if you want to design and optimize these unit processes. And there are advanced treatments available, like membrane filtration methods like micro, nano, or RO filtration. and ion exchange, DAF. Those are the very advanced filtration, advanced treatment method. However, the selection of the best treatment method, it should be based on, as I explained earlier, based on your water quality, the intended purpose of the water, cost, and O&M consideration. So, since the available, if you have available advanced treatment method, it is not advisable to blindly use those treatment method, because the cost and operation and maintenance concerns are there. And water treatment is start within the catchment. If you want to have a proper water treatment, you should protect your catchment. It's no point of polluting the water at your catchment and treat it again at the using place. That is a waste of resources and waste of money. So the drinking water treatment should start in the catchments. And the new challenges for the drinking water treatments are anthropogenic chemicals like pharmaceutical, personal care products, fertilizers, pesticides, heavy metal, and also the scarcity of the water due to the climatic change. All those are the new challenges for the drinking water treatment. So we have to address those in the future. So the conventional water treatment may not be enough to address this or to remove this contaminant from the water. So it is best way or advisable best practice is to preserve and protect your treatment, your catchment, your water source, and conserve water. That is the best advice for the best way to do the water treatment. Anyhow, thank you very much for all you for listening to me, and it's time for the questions.
Thank you, Anuruddha. And before that, I can see here our water treatment specialist, Mr. Ratnayaka is water board water treatment specialist. Mr. Ratnayaka also joined. Not questions from the specialist, but we expect certain opinions regarding our upcoming experts and their opinions. Mr. Ratnayaka, can you speak for 2-3 words?
Okay. Thank you very much, Daraka, for asking me to giving me an opportunity to give my ideas here. I am sorry. In the middle, I could not listen to the. I was looking at the presentation slides, but I could not listen. But at the beginning and at the end, I could pay my attention to that. Anyway, I am really happy to see at least few engineers are concentrating on this subject, because earlier we did not have many engineers who really interested in water treatment. Though they did their designs, the dedication, the required dedication was for the other subjects. But here, Anuruddha is trying to improve the knowledge level in the water board. And therefore, I am really happy to see that. And he went to the history of the water treatment, and therefore it is and he mentioned about the water treatment, ancient water treatment systems in in Sri Lanka. Normally people think that water treatment is a subject introduced by the foreigners or the Western countries, but the real case is we were much worried for the water quality in the past.
Thank you very much, Engineer Director. Shall I add something? Oh, thank you very much, Engineer Ratnayaka. Boss, dear boss. So your comments and your words are very encouraging. So
we have selected the source so that those problems are not there. Therefore, really we are concentrating on removal of organic pollutants as well as inorganic trace metals also. Anyway, thank you very much, Anuruddha, for doing this presentation, the interesting presentation, and we'll look forward.
Yeah, shall I ask one question, Mr. Anuruddha? Fernando here.
Sure.
Mr. Anuruddha?
Yeah.
Yeah, actually, that screening area, coarse screen and fine screen.
Yeah.
Can you little bit explain that fine screen, you mentioned the size 1.5 to 13 millimeter up to, and coarse screen 32 to 100 Roy.
Yeah.
Just explain me that if we take a river intake, we are going to use manual screen. No, not mechanical, not band screen. In that case, this just idea about this fine screen sizing, just to get an idea.
Yeah. Okay. Now what is your water source?
Actually, source is river intake. I am asking that actually the local area, some season flood is coming. This already there, but some questions or some problems.
Yeah. The thing with the water treatment, we cannot recommend value that is suitable for everywhere.
Yeah.
Okay. So we have to first study the quality of your raw water. Then, if you have a idea about every water source is different from another water source. That's why we have a range. Okay,
yeah,
we are not giving a specific value for the opening because every water source is different from another water source. So you have to study your water quality.
Correct.
Then you have to find the best suitable the opening size for your speed. So normally the best way for the doing the designing for water treatment, you have to study the raw water
quality according to the subject. Yeah.
At least 1 year. Then if you are lucky or luxury, you have a luxury to have a pilot plant operated for at least 3 to 6 months. That is the best way to do the install a proper water treatment plant. But I know that in Sri Lankan context we are not doing it. Okay, we are putting the water treatment plant somewhere here there, but that is not the proper way to do that.
Correct. Right, I understood. Some problems maybe we'll discuss later. They are not relevant to this presentation. Maybe for knowledge we'll discuss later. Right. Thank you very much.
Sure, sure. Thank you very much. Okay, okay. So shall I just want to add something. I am very happy that Mr. Patnaik, our storage and water treatment specialist, also joined with this one. So he's the person who inspired me about the water treatment. Then I would like to rather learn about these Asian technologies used in Sri Lanka from him also. I'll come and meet you, sir, later. Discuss all those things.
Okay, we'll be in touch.
Thank you very much, sir. Engineer Ratnaka, water specialist to Water Supply and Drainage Board. Thank you, sir. You are present here. We are very pleasure about that, and thank you very much for the comprehensive introduction session, Engineer Anuruddha, on the drinking water treatment process. You sharing your knowledge with us today. So next, I'm going to do the next part quickly. Before conclude the sessions, I would like to invite Chairman to the session 2022 and 2023 IESL Kegalle District Chapter, Engineer Daraka Vitarna, to deliver vote of thanks speech. Sir, please.
Thank you, Buddhika. And first of all, I would like to take my pleasure to Engineer Anuruddha Tilakaratna, as well as the Aqua Faculty. I think Mr. Kishan Chandrasekhara is also present here. I would like to extend my gratitude to both of you for being volunteer to conduct this session. And I think for this year, this is the first webinar we are conducting, but last year we conducted many. This is the first one we are conducting within this year. I think in another way, this will be a very fruitful and very productive session, especially on water treatment. I think water treatment is a very, in certain way, it's a simple one, but a very interesting one. But most of the engineers are thinking this is a very complicated process. Therefore, I think by the presentation done by Engineer Anuruddha, I think all might understand that this is a very interesting and a very, if somebody get the fundamentals to their mind, this will be a very simple one, but otherwise it will be a complicated. I think all our Engineer Anuruddha will agree with me. So anyway, this will be a good one, and most of our young engineers joined this program. I saw. I encourage them to attend this kind of program. We will conduct in our chapter as well as IESL, some other chapters and mother center in future, or else some other institutions also join them, and it will be a great opportunity for the young engineers. Anyway, at last but not least, I again extend my gratitude to our resource person, Engineer Anuruddha Tilakaratna, regarding conducting this program successfully. And I pay my gratitude to Engineer Kishan Chandrasekhara, the director of Aqua Faculty, for extending his valuable resources and support assistance to IESL in many ways. Sometimes he prepared the flyer also in many ways, because these days Kegalle chapter is busy with the Bakmahaulela. In that Buddhika. So we are very tight program on Bakmahawulala that is to be conducted on 30th this month, that is Sunday in Galigamu. I want to invite you all for that program also, especially the engineers who stay around Kegalle. You all can join with that on Saturday with your families. So in such a tight schedule, Engineer Kishan prepared that flyers on behalf of representing IESL as well as the Aqua Faculty. So I pay my thanks again for this one. So and I would like to remind all our attendees regarding presence here. One way it's a good opportunity for you, and other way as IESL we treat your attendance is a good honor to IESL as well as to the resource person. So thank you very much. Finally, I would like to thank our moderator and as well as our secretary, IESL Kegalle District Centre, Engineer Buddhika Patiratna, for conducting this one in balanced way. Whenever comes difficulties, he is supported. So well done, Buddhika. So thank you very much in other way. I'll conclude my vote of thanks, and we'll meet with another fruitful sessions in coming months. We expect to conduct many programs like this, one for 1 month from our district center. So please join with us, and thank you very much for giving me this opportunity. Over to you, Buddhika.
Thank you very much, sir. Engineer Daraka Vitarna, President to the IESL Kegalle District Centre. Okay, I declare this session is over. So thank you very much for being with us at the time. Engineer Anuruddha, very thank you for your conduct this session. Thank you very much, sir. Thank you. Okay.